Hi guys, I'm your maths faculty from QLS Academy. In the last session, we studied about addition and subtraction of algebraic expressions. Now today, we will do the last two topics of the chapter. I hope you'll have fun learning, so let's go. As we all know that the value of an expression depends on the values of the variables forming the expression. And there are a number of situations in which we need to find the value of an expression, like when we wish to check whether a particular value of a variable satisfies a given equation or not. We also find values of expression with the use of formulas. For example, the area of a square is s square, that is side square, where s is the length of a side of the square. If s is equals to 5 centimeter, the area is 5 square, that is 25 centimeter square, and so on. We shall see more such examples in the next section. Now, let's start with some question solving. The first question says, find the values of the following expressions for a positive value of x and take x is equals to 2. Here, the first expression is x plus 4 and the second expression is 100 minus 10x cube. So, in the first expression, which is x plus 4, when we put x is equals to 2, we get x plus 4, which gives us 2 plus 4, which is equals to 6. Now, in the second expression which we have is 100 minus 10x cube. When we put x is equals to 2 in it, we get 100 minus 10x cube is equals to 100 minus 10 into 2 cube, which gives us 100 minus 10 into 8, that is 100 minus 80, which is equals to 20. Now, the next question says, find the value of the following expression for a negative value of n. In the previous question, we had a positive value of n. In this question, we have a negative value of n. So, the question says, find the value of the following expression for a negative value of n when n is equals to minus 2. So, the first expression we have is 5n minus 2 and the second is n cube plus 5n square plus 5n minus 2. Now, in the first expression, when we put n is equals to minus 2, we get 5 into brackets में minus 2 minus 2 is equals to minus 10 minus 2, which gives us minus 12. Now, in the second expression which we have, when we put n is equals to minus 2, we get n cube plus 5n square plus 5n minus 2, we get minus 2 ka cube plus 5 into minus 2 ka square plus 5 into minus 2 minus 2, which gives us minus 8 plus 20 minus 10 minus 2, which gives us 20 minus 2, that is 0. Now, let's see cases when we have expression of two variables, for example, x plus y or xy. So, the question says, find the value of the following two expression for a is equals to 3 and b is equals to 2. So, the two expressions which we have are, first one is a plus b and the second is a square plus 2ab plus b square. Substituting a is equals to 3 and b is equals to 2 in the first expression, that is a plus b, we get a plus b is equals to 3 plus 2, which is equals to 5. And substituting a is equals to 3 and b is equals to 2 in the second expression we have, that is a square plus 2ab plus b square, we get a square plus 2ab plus b square, which is equals to 3 square plus 2 into 3 into 2 plus 2 square, which is 9 plus 2 into 6 plus 4, which is equals to 9 plus 12 plus 4, which gives us 25. Now, the next question says, what should be the value of a if the value of 2x square plus x minus a is equals to 5 when x is equals to 0. हमें एक एक्सप्रेशन दिया है जिसमें हमें a की वैल्यू फाइंड करनी है एंड उसको हमें पहले बताया गया कि उसकी एक्सप्रेशन की वैल्यू इज इक्वल टू 5. So, the expression is 2x square plus x minus a, which is equals to 5. Now, by putting x is equals to 0, we get 2 into 0 plus 0 minus a, which is equals to 5. Hence, the value of a is minus 5. Now, the next topic for the day is formulas and rules using algebraic expressions. We have seen that the formulas and rules in mathematics can be written in a concise and general form by using algebraic expressions. We can see several examples of it below. The first one is the perimeter formulas. The perimeter of an equilateral triangle is equals to 3 into the length of its side. If the length of the side of the equilateral triangle is L, then the perimeter of equilateral triangle is equals to 3L. The second one is the perimeter of a square, which is equals to 4L, where L is equals to the length of the side of the square. And also perimeter of a regular pentagon is equals to 5L, where L is the length of the side of the pentagon. Now the second one is the area formulas. Now if we denote the length of the side of a square by S, then the area of the square is equals to S square, that is side square. Similarly, if we denote the length of a rectangle by L and its breadth by B, then the area of rectangle is equals to L into B, which is equals to LB. Similarly, if B stands for the base and H stands for the height of a triangle, the area of the triangle is equals to half into base into height, which is equals to B into H by 2, which is equals to BH by 2. For example, for a square of length 4 cm, the perimeter is obtained by putting the value of L is equals to 4 cm in the expression of the perimeter of a square, that is 4L. So the perimeter of the given square is equals to 4 into 4 cm, that is 16 cm square. Now the last topic for the chapter is pattern. The first one is number pattern. The rules are, first one is, if a natural number is denoted by n, its successor is n plus 1. I repeat, if a natural number is denoted by n, its successor is n plus 1. We can check this for any natural number. For example, if n is equals to 10, its successor is n plus 1, that is 10 plus 1, which is equals to 11, which is known. The second rule is, if a natural number is denoted by n, then 2n is an even number and 2n plus 1 is an odd number. Let us check it for any number. Say n is equals to 15. So 2n is equals to 2 into n, which is equals to 2 into 15, that is 30, which is an even number, and 2n plus 1, which is equals to 2 into 15 plus 1, which gives us 31, which is an odd number. Let us now look at another pattern of numbers, which is 3, 6, 9, 12 till 3n and so on. The numbers are such that they are multiples of 3 and arranged in an increasing order, beginning with 3. The term which occurs at the nth position is given by the expression 3n. Also, you can easily find the term which occurs in the 10th position, which is 3 into 10 is equals to 30. Now comes the pattern in geometry. So, how many diagonals can we draw from one vertex of a quadrilateral? So for it, we will draw a quadrilateral and try drawing diagonals from one vertex of it. तो इससे बस एक ही diagonal बन रही है. Therefore, in a quadrilateral, there is only one diagonal from a particular vertex. Similarly, from one vertex of pentagon, we can draw only two diagonals. So, note that the number of diagonals we can draw from any vertex of a polygon of n side is n minus 3. Now, let's do some questions on it. The first question says, observe the patterns of the digits made from the segments of equal length. You will find such segmented digits on the display of electronic watches or calculators. The figure is given. So the first symbol is 6, which is in the shape of 6. So the digits number are 5, 10 and 100, and the patterns formula is 5n plus 1 as given in the figure. So the number of segments for each digit number which we get are, for the first one, that is 5, we get 5 into 5 plus 1, which is equals to 25 plus 1, which is 26. Now for the second digit number, that is 10, we get 5 into 10 plus 1, which is 50 plus 1, that is 51. Now for the third digit number, 100, we will put this in the pattern formula, that is 5n plus 1, we will get 5 into 100 plus 1, that is 500 plus 1, which is equals to 501. Now the second question says, use the given algebraic expression to complete the table of number pattern. So here is a table that is given, and in the first expression we have to find the 100th term, and in the second expression we have to find the 5th, 10th and the 100th term. Now the first expression is 2n minus 1. Over here we have to find the 100th term. So we'll substitute n is equals to 100 to get the 100th term. So by putting n is equals to 100 in 2n minus 1, we get 2 into 100 minus 1, which is equals to 200 minus 1, that is 199. So 199 is the 100th term in the expression 2n minus 1. Similarly, in the second expression, that is 3n plus 2, we have to find the 5th, the 10th and the 100th term. So by putting n is equals to 5, we get 3 into 5 plus 2, which is equals to 15 plus 2, which is 17. 17 is the 5th term of the expression 3n plus 2. Now to find the 10th term, we'll substitute n is equals to 10 in the expression. We get 3 into 10 plus 2, which is equals to 30 plus 2, that is 32. Similarly, for 100th term, we'll substitute n is equals to 100 and we get 3 into 100 plus 2, that is 302. Therefore, the 5th, the 10th and the 100th term of the expression 3n plus 2 is 17, 32 and 302. So today we studied about how to take out value and solve the expression and about the patterns. I hope you understood today's topic and keep practicing the questions, and for any queries do contact us. The link is given below. Thank you and have a good day.